The thing that sits at the core of that race and making that very possible at scale on Ethereum is ZK.
We're just going to continue building out that hyper network through use of ZK TLS.
I'm already seeing very interesting use cases of verification through ZK of information.
The wider dream here, and I think the big vision, is that like, hey, ZK actually should probably be underpinning all of our data. Hello, today we're going to talk a little bit about zero knowledge proofs, state of the industry, and where we are today. The ethos of Web3 lines up very well with what ZK has to offer in terms of privacy and verifiability. And as such, there's no surprise that the Web3 community have been sort of the first adopters of what is a very exciting and ultimately might be an all-encompassing technology here for the future of data. And so my name is Einar. I'm one of the partners here at CoinFund. I think inside of our portfolio, we have the majority of ZK proofs generated and consumed today. And around the table, we have a couple of the largest players in this space. And so I'm very excited to host this roundtable today. Now, with that said, maybe we can go around the table and quickly introduce yourself. Jack, do you want to start?
I'm Jack. I'm co-founder and designer at Icebreaker, where we are an open professional network that lets you hire through warm referrals. That's what we're really focused on right now. And we use ZK to let you pull out your LinkedIn connection data.
I'm Omar, Azhar, head of business development at Matter Labs, which is the company behind ZK Sync. ZK Sync essentially offers the ZK stack and is building the Elastic network, which is essentially ZK rollups, ZK Validiums, L2s built on top of Ethereum that anyone can use to build their own either private permission chain or fully public permissionless chain. And the Elastic network is the network that's connecting all these different chains together with ZK-based interoperability and scaling the applications through ZK.
Yeah, I'm Stasia Carson, co-founder and CEO of Sindri. We provide a very easy to use and powerful platform and API that connects developers with the cloud infrastructure that's required to build, deploy, and scale applications that leverage zero-knowledge technology. A lot of people think of us as sort of the Stripe or the Vercel for deploying zero-knowledge infrastructure. We are one of the fastest growing players in the space, and our customers are protocols like ZK Sync, as well as rollups, applications, and some other really exciting use cases that are leveraging ZK today.
Wonderful. Thank you guys for coming. As you also mentioned, we are in Denmark for ETH Denmark today. So lots going on here. And so we're going to build on top of that energy, I hope. Maybe we can start with the question of why now is the right time for ZK adoption. I think we had a pretty monumental moment in 2023 where ZK Sync launched mainnet and became, I would say, one of the first commercial users of proofs for an actual use case and also paying for the generation of those proofs. So Omar, maybe this is a good one for you to start, but curious kind of how do you think about the demand for ZK? What have you seen? Where are we today?
Yeah, so I can speak from the application and chain side of the ZK space. So I'll say, so we launched our first mainnet in the spring of 2023. That was the first ZK chain for ZK Sync within the overall Elastic network. Since then, last summer, we launched ZK Stack, which is essentially your own ability to launch your own chain or app chain or ecosystem chain. And since then, we've seen a significant demand go for people or either you're a crypto native founder, crypto native team, or you're a large institution that like centralized exchanges, potentially banks that are looking at ZK rollups or ZK Validiums as a way for them to build on top of Ethereum, right? And on their own terms, because they can do a lot of different customizations. You can pick different DA layers. You can change the sequencer, make it more performant. You have account abstraction as well. So the demand that we're seeing is on the app, is really playing into the app chain thesis, right? And using zero knowledge proofs, it's arguably the most secure way of scaling Ethereum, right? No withdrawal delays. Transactions are validated with ZK at point of transaction. And then we've also have interop coming as well, right? So all these different chains that are launching, they will be able to trustlessly send messages, send ERC20 tokens, send NFTs across to each other, right? And so a lot of the demand that we've seen since we've launched ZK Stack has been on the app chain side. We've got teams like Abstract and Buggy Penguins launching their own L2 as a ZK ability, and you've got Lens, which is going to be launching the Lens chain very soon. You've got Sophon. We recently announced a large number of centralized exchanges are also looking at ZK as a way for them to come and build their own layer 2s on top of Ethereum, right? We have Ripio that announced last month they're going to be launching their mainnet pretty soon. So that covers a lot of the exchange flows in Latin America. We recently just announced WonderFi. That's a large centralized exchange in Canada. Union Chain, which is very interesting because essentially you have all the big exchanges in Southeast Asia combined together to build their own layer 2 as well. And then now we're seeing a lot of additional institutional adoption for ZK technology for their own app chains. For example, Deutsche Bank with Memento blockchain, they're on testnet. They will probably be launching mainnet at some point, like very soon as well. So I think it's offering essentially anyone to come in and build on top of Ethereum, but have all the customizations they need while ensuring security through ZK technology.
I think you probably know the space, at least your go-to-market better than I, but I imagine, when you're selling to anybody, in particular in institutions, you need to be able to offer like just a full-scale solution and less of a technology. And the way I see it is that we've sort of been building these layers and layers of abstraction where, a lot of stuff now comes built in. So you've got built-in utility, built-in scalability, configuration, and like really nice, clean access patterns. And I imagine like now, we move from theoretical to real world, and you can now go sell this really interesting proposition to these institutions and say, hey, it's pretty turnkey, which I think is pretty powerful as well.
Yeah, I think integrating further like different APIs, like, hey, okay, yeah, the same way you just deploy servers for any application right now, you either go to AWS or GCP or Azure. We're moving towards a world where essentially app chains become the same thing, right? And I think ZK is very important to that because it allows you to build this in a like trustless manner and a much larger overall public network built on top of Ethereum. So you get access to Ethereum, and you get access to whatever larger stack network they're on. In our case, it's the Elastic network with ZK Sync. But then the APIs and the ease and plug and play. So, for example, some teams might not want to manage different parts of the infrastructure for their chain, right? They say, hey, the prover, I don't want to have to train a team that knows how to run GPUs and knows how to run a prover. Let me just use Sindri, like, here's the API. I just send my transactions there, get the proofs, verify. Makes much easier for development, right? The cycles. Our goal as ZK Sync is to make the ability to launch, run, operate an app chain that's customized for your business needs, whether it's privacy and permissioning because you have KYC requirements, whether et cetera, or other use cases, be super easy and fast. And having components like Sindri plugged in automatically in there makes it so much faster for them.
Yeah, that makes a whole lot of sense. And I think, and one thing that was interesting to us and like which we're seeing is that, hey, it's really being used for scale. Like in the beginning, everybody was very focused on the privacy piece of this and like, hey, that's kind of the major thing. But actually it turns out, at least for now, the verifiability is sort of the main thing, right? That like, hey, I can actually, if I use this, I do get access to Ethereum. I can scale it at like a very cost efficient and manner. All right, so we are seeing we're seeing real demand and traction for CK already today, which is a bit of an eye opener. I think there's also a number of emergent use cases and ways to use CK. Jack, like I know you guys use CK-TLS a lot. Maybe you could just quickly like give us the 30-second on what CK-TLS is, and I would love to kind of get your thoughts on what that unlocks for you and potentially for others.
Sure. Yeah. I mean, what ZK-TLS is, zero knowledge transport layer service. We use that basically as a way to allow our users, like as a professional network, we're very interested in obviously your professional data. So we use that to allow our users to go through and pull out their entire LinkedIn connection network in one go into our application. So now we can actually rebuild that social graph outside of LinkedIn, right? And we feel that, that's from the user's perspective. So they're able to go complete this. And the ZK-TLS, basically the user is interfacing with LinkedIn. They put in their, username, password, they pull that data. And the ZK element is saying this data is true and correct and verified and real. So now we say, okay, we believe you. And now we can use all of those contacts. And now you have your entire LinkedIn contact list outside of LinkedIn. And now you can go do interesting things with that. So that's really how we're using it primarily in our app.
Got it. Yeah. So at the highest level, CKTLS is really a way of verifying. I'm not sure I want to say real world data, but data other places outside of that proof, right? And with that, you can kind of, hey, that can be emails, that can be passports, payments, whatever kind of you're doing, and then you can actually prove to an app or to somebody that like, hey, I've actually done this, right? So that is very in vogue right now, and kind of one of the largest new use cases, I would say. But Stacia, kind of maybe you can touch a little bit on like kind of the current use cases and what you're seeing. Granted, you have, I think, well, if not all, then definitely the majority of the customers who are consuming CK proofs today. So curious kind of what you see.
Yeah, it's funny. When we initially went to market, I think our thesis was heavily baked around application builders leveraging ZK in really interesting ways. And they would need to offload that infrastructure burden to some sort of managed infrastructure layer. And I think that while that is definitely materialized, where we're seeing the most demand come from is, frankly, like we think that scalability and more so performance is sort of this like renewed space race in blockchains right now. And particularly in Ethereum, where we're seeing like very high performant execution environments, gaining a lot of traction and gaining a lot of awareness and like really enabling this new class of use cases. And so as a result of that, the thing that sits at the core of that race and making that very possible at scale on Ethereum is ZK. So the majority of demand that comes our way is from teams that are super aggressive and wanting to really push the boundaries of what's possible from a throughput standpoint. Omar, you touched on like the necessary elements of configurability. I want to run it with the things that I love about crypto, but I want to run it without things that I don't like about crypto. And so these very like enterprise shaped opportunities are where we're seeing a lot of the demand pull from. And what they need is one, a trusted partner, two, a trusted stack, and three, just a way to sort of deploy this in a very consumable way. We talk at Sindri a lot about making it hyper consumable. How do we make this as easy as possible to deploy with, whether that's a few lines of code or like single click. And I think that's, all of this is converging at the right time, the right place. We're seeing a lot more institutional awareness and friendliness towards crypto and sort of how they unlock things like post-trade efficiencies and other like efficiencies that are gained on probably the most efficient global payment rails that are in existence today. So that's where we see a lot of our demand coming from on Sindri. But there are fringe use cases where we've got some interesting apps that are using us to do some off-chain compute, to tally like game scores or some other sort of auxiliary data, and then bring that back on chain for their users. But it's really like, I think what's in the mainstream focus right now is how do we scale? How do we drive performance to meet enterprise thresholds? And then how do we maintain some level of configurability? And that's sort of, what we are able to provide to our customers. And I think that's where a lot of the downstream demand is coming from as well.
I think you really like our roadmap. We're trying to get to 10,000 TPS per chain by the end of the year. Yeah. A lot of transactional throughput demand right there.
It's so key, right? Like, I think that the success, whether we like it or not, of the Solanas of the world is really pushing us towards like, how do we get out of our own way and enable these really cool use cases while still maintaining the security that Ethereum provides.
The big thing is once you have a stack that can get to Solana level performance, which I think we will try and get to by the end of the year. If you can do chains that can do 10,000 TPS, every transaction is validated by $0 proof. You don't need a validator set.
That's such a good point. Yeah.
So now automatically you can just build a centralized server, but that centralized server can't create wrong transactions, right? So they can't take your funds, they can't sign on your behalf. And I think that's a very interesting design for different centralized exchanges. Like that's why they can come on, not have to worry about, oh, I need a validator set. No, every single transaction's validated with $0 proof. So your users can sleep easy. And Gravity is one of our chains. They are a regulated DEX. They have a license in Bermuda. They're going to try and get a license in US and Dubai soon as well. They've been live for 2 months, doing about 100 million in transaction volume every day. But they're essentially, it's almost like a ZKTLS almost use case because everything's done off chain, right? So the order book matching engine is completely off chain. So they can get to, centralized exchange level performance, 100,000, 200,000 TPS. But when a transaction does match, they just use ZK to prove it. And that is what actually goes on chain, right? So there's a lot of different ways you can start doing validation of events, transactions, etc.
Totally. And I think that, like, generally speaking, like, there's a very academic understanding of ZK. but like practically speaking, ZK scales state. And so that's what we're talking about here is like, you can do that in like probably the most efficient way. And as we make it more accessible, it just becomes a no-brainer proposition. Like, this is the way that we're going to do this. So I think you're spot on. And the validative comment as well, like doing this in a lightweight, cost-efficient way is important too, where we remove like the bootstrapping needs of recruiting like large validator sets, and we're able to like literally spin one of these things up in minutes or hours is really powerful.
It's like how it's so expensive to run a decentralized infrastructure, right? Like, I think all the big chains have to do huge amounts of inflation. Like Solana, I think, has a couple of governance decisions to make over the next couple of weeks around, burn versus inflation to the validators. At the end of the day, it's a massive cost. If you can take out that cost, it's huge for anyone wanting to build a secure and performant like app chain.
Definitely. And I think so we're kind of touching on something that I think we've been spending some time on over the last couple of months, which is the, centralization versus decentralization of provers and networks. And there's been a, discussion in the industry, I would say, of like, hey, do we need decentralized networks for this, or can you actually do it centralized? So Stasia, maybe curious to just get your baseline view here, and then maybe for you guys as users and builders of this technology, curious to hear what you think too.
Yeah, it's a good question. I'm gonna provide like a balanced answer here, because I really do think it depends on the use case. I think for like large protocols and like native protocols, like I can see decentralizing the prover as being a key to aligning with ethos, but also just generally getting the properties of what decentralization brings. As it relates to like our customer set, I think it's not super critical. I think that some of the main arguments around decentralized prover networks and marketplaces is that ultimately you can find the most cost efficiency by virtue of decentralizing some sort of marketplace. And so you're doing a lot of price discovery and other actions that will ultimately drive you to the most optimized price point. And I think that's just given the demand and the other macro trends that are happening in the GPU space right now, I think that's probably far from the truth. As it relates to like our own ability to find pockets of really nice value, like cost value from a GPU acquisition standpoint, we find that partnering and being really thoughtful about like your hyperscaler and multi-cloud strategy can actually get you to a place that's either at parity or better, and in particular at scale. So if we move outside of just like the economics of why these may or may not make sense, and think about it practically as like, all right, I have a customer who's hyper-focused on distributing some sort of mission critical compute workload and having that processed on some back end in a reliable way and functioning more like an enterprise or more like a startup that wants to scale really quickly, but know that the lights are still on, when they go to bed. I think that decentralizing proving actually introduces a lot of overhead and some unintended. Number one, I think that there's like an inherent misalignment of incentives. I think like as a business operator, my number one priority is to make our customers happy and to not add in layers of complexity, overhead, and incentives that are related to some market making action. But I think when you start to think about how do I prop up a market or support market making actions in order to gain enough supply or enough demand to actually market make, I think that you get a little distracted and you move a little bit away from like the mission, which is ultimately servicing your end customers. And then second, there's just like a lot of complexity overhead that's introduced when you're trying to, essentially expand what is already a really hard fundamental problem, which is like global distributed compute, in a way where you have to have scale at any moment in a very like reliable manner. So one of the benefits of Sindri thus far in running these L2s at, in production is we know what the shape of these workloads look like, and we know what the auto scale requirements are to service these at peak times. And so what I would be worried about as an operator is, is there enough like compute liquidity in this marketplace to service peak load? Will I be impacted? Like, do I have any transparency or control or ability to budget what that would cost if I go from, 1 TPS to 10,000 TPS? How do I map that cost increase? And just visibility into the pipeline. Like there's simple questions like, what is your cold start? And cold start is measured by the time that you receive some sort of request to when the machine actually starts doing work. And a lot of that stuff is just ambiguous in these networks. And so, to sort of bring it to a head, I think for our customers, they value reliability, stability, scalability, and at the end of the day, somebody that they can trust, that they know is deep in the infrastructure and is like single-minded in just making sure that their chain, their protocol, their app is working and optimized.
I guess a good use case would be like, since you have the direct relationship with the end customer, they can also tell you, hey, this is what my roadmap's looking like. Friday, I'm going to have this massive event and my throughput demands are going to skyrocket at around 10 a.m. on Friday, right? And so you can kind of almost have the scale, like the servers ready to go, right? Whereas would you say a decentralized proven network might take more time to realize, hey, there's more demand. Okay, the marketplace is the price is going up, then the demand comes.
Yeah, I think it's a question of elasticity, right? Like per unit of input, like what is the per unit of input on the demand side, how do I match that one-to-one on the supply side? And in marketplaces, that's why there are marketplace efficiencies. That's why MEV exists and just external marketplaces, is because there's always an imbalance. So for me as a business operator, right, like, because we get approached sometimes by decentralized utilities that we could use, I just can't take the risk that something's not there to service my workload when I need it. Like if Google said, hey, you know what, like maybe it'll cost like $2 today, but it could cost $4 tomorrow. Or maybe, we can get up to 200 GPUs, but 201, like that's gonna be really hard. Like that uncertainty as a business operator, like I couldn't sleep at night. And so I know that people put all of their effort and work into building these amazing applications. And the last thing I want to do is put them in a position where I can't, service them with the supply and thing. So
It's almost similar to like the blob space issue.
totally,
Right
yeah.
now, right? Congestion goes up. Well, fees should still be the same.
Yeah.
Right. So
we take the optimization at every single layer of the infrastructure pipeline very seriously. We have a lot of like retry logic and automation. So like if a lot of people don't realize, like at the GPU level, a lot of stuff can go wrong because a lot of GPUs are architected for AI workloads. And like at the bit level, it doesn't need to be hyper accurate for AI, but for cryptography, it does. And so you have to really understand how to build in all these mechanisms such that if you have a corrupt GPU, you can move on to the next one and not lose your progress in some sort of like recursive proof chain or other ones. So yeah.
Yeah, and I think one thing that is important to keep in mind as well is that, like, yes, there are certain benefits to decentralization, right? But especially if we're looking at, normal chains, say like asset ledgers, it's actually verifiability, right? That like, hey, you can check it with the third party. Everybody has the same version, right? But in CK, that is actually kind of inherent in the proof itself, right? So that piece of like the decentralized value proposition, if you will, does not necessarily apply to ZK.
Totally.
Right? Because, hey, it's mathematical proof. You can just go and verify it yourself. You don't really need to like have third parties verify it.
Absolutely.
And that kind of changes the whole dynamic really between why do we need the centralized prover networks versus centralized providers. And like, hey, how does it, then the trade-offs kind of become a little bit different. Jack, how did you guys think about this, if at all? As like kind of a company innovating using CK and actually building apps and like kind of use cases on it.
Yeah, I mean, it was mostly like you were saying, it's the time. Like now is the time for ZK data. It's like we can now do this. Like we didn't have the ability to do this before at all. Like it wasn't even an option even just like 2 years ago. You couldn't go get this verified data from these centralized platforms and take it out and do interesting things with it. I was talking to Dan about this morning, and he was saying that ZK is like Plaid in that ZK is for data, Plaid is for financial services. The difference was that financial services had an incentive to like come together and work with Plaid and have that data flow. And whereas these Web2 companies don't have any incentive to do that. So they aren't going to come to the table to work with the ZK solution in terms of moving that data out of their services. So it's great that we now have this ability to do that for the user who wants to take that data out, to do new interesting things with it, to have interesting consumer applications Like we get asked all the time about, oh, I want to prove this badge, I want to do this, I want to prove this thing. And that's interesting to us in our Icebreaker profile, because we want you to represent like who you are. And now that we're in this new age, 20 years have gone by, we have all of these different profiles, different services, things we've done online that are big parts of our lives that we can't represent because those platforms won't play with each other, right? Like, give me my data. Like, you're making it hard. Why do you make me go through 10 clicks to get my data and wait a week, right? And because you forget that you requested the email, it ends up, you forget you requested that. So just really a thrilling time that we could even have the ability to allow a user to take their data out of LinkedIn, right? I'm thrilled. Like, now we've built a better search than LinkedIn in Icebreaker of your LinkedIn contacts. And I have all my Farcaster contacts and the Icebreaker contacts. And we're just going to continue building out that hyper network through use of zk-TLS. So I'm pumped.
That's awesome. I'd love to hear that. And how prominent, if at all, is ZK to your end user? Is it like, hey, totally abstracted away, like this is just like a normal consumer experience?
I mean, as probably the most like retail-ish individual at this table, I don't want to know about it. Like, you know what I mean? And speaking with a few of our marketing, we're talking with some marketing friends, and he was basically saying, never ever talk about that. Just don't ever do it. Like, if you're talking to end users, just please God, never say zk-TLS, which I was like done, easy. The important part is, what do I get to do with that? And it's, now you have a better search across LinkedIn. Now you get to see, who is everybody I know who's ever worked at that company, right? And what's my ordinality? Oh, I actually know that guy on Twitter, but I didn't know, we weren't connected on LinkedIn, but now I can see his job through Icebreaker because we have this unified profile. So yeah, I personally am a proponent of not talking about it, but making the value real, making it easy for people to use, and like end people, like LinkedIn people, like Web 2 people, right? And I think there's a bridge. I kind of have this concept of us, there's Web 2, Web 3, and there's a huge opportunity in the bridge between those, right? Like Dan and I both came from Google and Coinbase, lesser to extent, but very talented Web 2 people that are like, where do I start? Like, I'm interested in this. And they're really technically talented people that can do that work, but they just need a little like bridge across, so we can hopefully be that place for them.
Yeah, awesome. And I would send him to Sindri, actually. That's probably where to start. And I think that's a good segue into sort of one of the next topics that I was hoping to discuss today, and that is kind of around ZK diffusing and permeating Web 2 and like the broader landscape, right? Like, we've sort of established, hey, there's current demand in Web 3. It's in use today. People are paying for this. But like, kind of the wider dream here, and I think the big vision, is that like, hey, ZK actually should probably be underpinning all of our data. All the databases out there, the whole internet, the whole payments rails, like, because it enables a couple of amazing things while maintaining privacy so well. And so I'll leave this open for anybody who wants to kind of take a stab at this. Be curious, what have you seen? How do you think about this? Like, kind of the people that you've been talking to from Web 2, like, kind of where do you see this going? And kind of how do we reach that end state of things?
I guess you can start off with what data belongs on a blockchain versus what data is like, we don't really need to change it. I just need to verify it.
Yeah.
Right. Passport data, identity data, all of that, right? We're not going to put that on the blockchain, right? All things. I think it's probably still going to be on my passport data probably should be on a government server, and I should just be able to verify, this is who I am, this is where I was born, this is my citizenship. We're already seeing that from governments like Argentina and Buenos Aires. All that is already verified on chain. You can just have it in your Miba app, verified to anyone like a bank or a cop, like, hey, here's my driver's license. The data doesn't stay on chain. It's just verified there, right? I think there's also interesting application in the payment space where you just need to verify like your email, or like what ZK-P2P is doing, which, hey, just verify your Venmo and you can onboard through Venmo directly on chain, right? That's a very interesting on-ramp that allows you to not have to deal with crypto on-ramps. You just use whatever app you already use for your personal finances and verified, okay, here's your USDC on chain. Other applications that were pretty interesting is just improving user experience. Like, getting away from crypto wallets, right? So there's ZK email, which essentially you can restore your smart contract accounts by email, right? Same way you do with any app restoration nowadays. Like, hey, forgot my password. All right, send me password reset link to my email. It's the same concept. We're moving towards that world with your user experience in your smart contract wallets as well. So right there already, I'm already seeing very interesting use cases of verification through ZK of information.
I think the way that I map this is if you think about how the evolution of stablecoins went and you map that to ZK, there's a very similar path, right? And today everybody looks back on stablecoins and says, oh, that's so obvious. That was the killer crypto use case, right? So let's go back in time and think about like 2017, where it was just like a really convenient way to park your funds without a ton of risk attached to it. And then we got into DeFi and we were able to financialize these stable assets and in terms of like yield generating sort of vaults and things of that nature. And then the commercial adoption came and we were talking about cross-border exchange as being this mind-blowing use case and digital currency at the government level, right? It's so obvious, like duh, look back at it. But they don't realize that it actually took a lot of incremental improvements in terms of like generally getting public understanding of it and generally figuring out like how do we really merchandise this technology. I think if you map that to zero knowledge in particular, you start with something like Zcash, which like the primitive was just like, how do we like hide identity? How do we hide what we're trying to do, either malicious or non? And then we're moving into this like scalability motion right now, which I think is sort of in between the stablecoin like hedge and financialization moment, but we're starting to see these pockets of commercial understanding and acceptance. And then we start layering in these other things that right now seem theoretical, but are actually possible around like selective disclosure and other sort of discreteness and that we can introduce into the model. And so like if you chart that path the same way as stablecoin, this is going to be that so obvious moment that we've been living in for the last 3 years or so, just because it makes so much sense, especially for crypto. But when we go out of crypto and we orient around this notion of scaling state, like how do we make databases play nicer with each other? How do we create efficiencies in counterparty transactions? All of that is enabled by trustless operations, and ZK does that, right? There's structural things that need to happen, but the same way you were alluding to, you don't want people knowing that it's ZK TLS in the background. Like think about all of the encryption technology that we use today just to surf the internet, and we don't even know it's there. Like we're going to get to that point. Right now, it's just more education and maybe over-explaining at points in time, but it will be so obvious that this was the technology that really like pushed crypto in particular to the next level and really drove us closer to that intersection between like commercial, financial institution and crypto.
The trustlessness aspect is super critical. Otherwise, we're building the same thing.
Yeah.
This is what we've already built.
And what is stopping that from happening today? Like, why aren't like all the world's databases today already run on zero knowledge proofs?
I mean, do you want to take that?
So if you look at tech transformations in general at like major enterprises, these are generally, 3 to 5, 8 year long transition processes, right? You generally start off with first a year or two's worth of just educating on what is this new technology, why is it better than current systems. Then you finally get to like a proof of concept, right? With maybe the enterprise has set up some sort of innovation team, and they're interested in these new technologies. You get a POC, you prove explain. Then you get into okay, let's try it with a brand, like maybe some aspect of that business with some little P&L like impact, right? Not really fully going into it. And by the time that's done, then finally people start understanding the tech, and then you get the hockey stick movement, right? I mean, it's the same thing with the cloud transformations, right? From the last 2 decades, that still took a while, but I think the biggest factors that gave the usage of cloud computing was the arrivals of Netflixes of the world, all new startups that completely created a whole new sector, and then all the old enterprises like, oh wait, I should actually move on to this is much better way of doing things. So I think we're still at that stage where we're beyond the POC stage now, right? The tech works, there's actual demand, there's things being built out, there's actual applications getting built out. I think now we're in the space where we're going to have very interesting startups like Icebreaker kind of build whole new sectors of applications that's going to significantly drive up the demand.
Yeah. And like space and time, like the technology is here.
Exactly.
Right. It's just the adoption curve of like, how do you get emerging tech into institutional level hands? And that just takes time. And it like, if there's anything I've learned from running Sindri, it's that like you have to slowly build credibility in order to have the enterprise level conversations. They want, again, like the solution. We're at the point where we've abstracted away a lot of the complexity. We've made it sort of behind the scenes, and we can sort of like one click deploy. And now it's just, again, like educating, making sure that we're getting it in the right people's hands. But there's nothing preventing, I mean, to be totally honest, like there's probably some latency, there's probably some performance trade-offs that you're introducing, but it's more an educational process. And how do we make this hyper consumable for that end user? And I think a lot of that technology, again, I point to space and time as being the perfect example of how do you like prove a database, and they've been able to do that in a really interesting way.
A lot of the institutions actually are well aware of ZK and actually been doing the research. Like St. Louis Fed, for example, I think wrote a paper on ZK like last year.
No.
How did you take it back up? But folks are starting to get a lot more interested, and they're starting to get more comfortable overall with the tech itself.
Yeah, and that's a good example. And I'm curious to ask like kind of what role does the government and Department of Defense play in this? Because we've certainly heard of a lot of like, hey, use cases and exploration inside of those entities, I would say. So curious, like kind of, and obviously defense has sort of been a major driver for technological adoption,
Yeah.
all the way back to like the 50s and 60s
Yeah.
and so forth. So like, and maybe there's things you can't say. I'm curious. I would love to kind of get you guys.
I can say everything. I have no affiliations. I think it's an interesting, so like at the end of the day, I think what national defense is most concerned about is manipulating source data and re-engineering risk. And what I mean by that is there is some autonomous vehicle or piece of equipment that gets caught in the field. It gets re-engineered to essentially infect the source code of wherever that data is being transmitted back to. And so some of the stuff that we've had conversations with on a theoretical basis more than anything is you can introduce a level of data opaqueness with ZK, because as you are able to essentially create this secure tunnel of data exchange via ZK, you can keep portions of data essentially hidden or off device. And so if it were to ever get captured, it never has the full set of data to effectively retrace back to the source with like a complete view of the infected data, if that makes sense. But essentially ZK can attest that there's been no tampering to the system. You're actually seeing teams like TikTok start to introduce this in TEE environments, right? So how do I test that the actual trusted environment is set according to some parameters? I can do that by essentially parameterizing a zero knowledge proof and running that, and then my consumer of that data should have trust that I've handled it in a protected way. That's effectively what we're considering, and what national security thinks is an interesting use case to sort of protect the home base, the headquarters source data.
All right. So one of the topics we haven't covered, we covered a lot of kind of drivers of demand here, but maybe one of the largest ones, and that is on top of everybody's mind today, is AI and what's going on there. And so, I think we can see probably multiple use cases of CK in AI, from everything around privacy to data verifiability and so forth. But curious to hear your thoughts, if there's anything that you've seen already, or you're thinking like, hey, this is where I see the CK space going when it comes to AI data. And I don't know, Jack, maybe you want to take a first stab at it.
Yeah, I mean, we were thinking about this a little bit this morning, in the local environment, right? Like being able to prove that you have your AI in your own local device, that it's yours. I don't really have a super deep take on the AI. It's become an integral part of my life already, right? So it's only going to get more important. And I guess we're seeing, I'm really closely watching just the decentralized AI versus centralized AI, I guess.
So this is going to be crucial.
Yeah.
Right?
Yeah.
Like verifiability of data, and like actually being able to like, A, figure out that it hasn't been tampered with, B, figuring out how to share it and manage access to the data, and C, also like actually end-to-end verifiability, right? That like you can you kind of remove the black box of data by being able to go back and say like, okay, these are the pieces of data inputs that came into the model. I can go back and verify that, which today you really can't. So yeah, I totally agree that this is going to be huge for open source and highly decentralized AI.
I think agentic future is like ZK has the potential to be the rails for agents, because anytime that you're exchanging without some human arbiter data or some sort of monetary exchange in a way that needs to be hyper efficient, super automated, these two agents need a way to verify around some parameters that some conditions have been met. And so that's what we're focused on, is, keeping our API super generalized and low level to enable any agent to effectively consume the API, send some inputs based on some parameters, and then run a proof that actually happened and then transact against that proof. I think is something that's really interesting and a couple years out. But if the future unfolds the way that we think it is, where there's thousands of AI agents and they're all coordinating together, it's not going to be as simple as just like giving it your credit card number, because there are going to be parameters, whether it's like color, shape, size, around what they're supposed to return with. And the merchant in that case is another agent, and they have to know, in a trustless way, that the exchange was done properly. So that's something that gets us excited.
Yeah, just real quick on that one. We were asked for the first time where we could verify that a bot was a bot the other day. So that's a great application there. Like it's like people wanting to verify that it's a person on both sides and they are who they say they are, but we're going to have trillions of agents. So you need to know that if I'm a human interacting with a bot, is it actually a bot? Prove it.
And if it's the right bot.
Yeah, totally.
Non-tampered bot.
Yes.
Yeah.
Are we seeing this today already? Is this like, or is this something that's like, hey, this is coming?
I think if we're being like super practical about it, I don't think that level, like, it's a requirement yet. I think that there are going to be human arbiters today that, as we start to like learn and give and lengthen the leash on these AI agents, they will still return and prompt us if this is okay or not. There is Moore's law happening all over different layers of AI. So would I be surprised if it was true within like a couple of years or even a year? Probably not. It's just that infrastructure hasn't been built out at scale, which I think is a big opportunity. But we've prototyped it on Sindri. We've got a little demo around like sending an AI agent to transact with an airline agent based on like seat preference. And it's not the perfect example, but it's just, again, like picking against an inventory list, sending that inventory list to the other receiving agent, that agent, testing that they did it the right way. I think that's like a really interesting solution space. So
Fascinating.
Yeah, can't wait for that. Personally, I'm like, please.
yeah,
Like
exactly.
after booking all the logistics for this week, I'm like, please, agents.
Yeah.
Like, when do we have that?
Yeah.
All right. Well, with that, I think we probably have spent our time here. Thank you guys for coming today and talk to CK. I hope we've sort of clarified a little bit around where the space is today, the demand, what we're seeing in the field in terms of like, hey, this is what's going on, and why we're all very excited about zero knowledge proofs and kind of where this is going. So thank you for tuning in.